Hi everyone. So this is an S1 normal distribution question, and here it is. It's quite a lot in an exam question, isn't there? I should just move and take case you want to take a screenshot of the whole thing, but what I'm going to do is I'm going to go through each bit at a time. So I'm just going to put each question up a little bit at a time just to make it more manageable. Now you've got a choice. You can either go through this at the same time as me, you can actually watch me do it, or you can pause the video, have a go at yourself, then unpause, see how you get on. I'll leave it up to you. Okay, the main thing is that you're watching and you're getting something from this. Okay, so we've got Geo, it's a computer program that randomly generates values from a normal distribution. He sets the mean as 40, standard deviation is 2.4. Find the probability of a particular value generated by the computer program is less than 37. Okay, so here we've got x is normally distributed with a mean of 40 and variance of 2.4 squared, standard deviation 2.4, and we need to find the probability that you've got less than 37. So probability x is less than 37. So to use the normal tables, we've got to use a standardized distribution, the Z distribution. So that is probability Z is less than 37 minus 40 over 2.4. Our value, subtract mean divided by standard deviation. So Z is less than negative 1.25. Now, I really like these normal curves. I'm a big fan of the normal curve, okay? Because it gives you an excellent visual demonstration of what's actually going on. So we need to find this. Okay, so on a normal curve, so 0, obviously, we need to find the probability Z is less than negative 1.25. So the area here, I've just shaded, is the area that's actually required. Okay. Now the normal tables don't actually do that. Normal tables use positive values. Okay. So we're going to find a way of working out what this is. It's a negative value. Using the symmetry, that is negative 1.25, that is positive 1.25. These two areas are going to be the same. So rather than find that area, we'll just find that area instead. Okay, and it will give us the same answer. Now we can look up probability Z is less than 1.25 because the probability tables work on probability is less than, and when you look it up, probability Z is less than 1.25 is 0.8944. So that means is all of that up to there is 0.8944, and because the whole probability adds up to 1, this little bit in here must be 1 minus that. Okay, so 1 minus 0.8944, and that gives us 0.1056. Okay. If you're a fan of using a calculator, you can use your calculator method if you want, but I'm a little bit old school and I do like using tables and graphs. Okay. Right, that's the first part. Second bit. So Geo changes the mean to m, but leaves the standard deviation of 2.4. Computer program then generates randomly 2 independent variables from this normal distribution. The probability that both of these values are greater than 32, 0.16. Find the value of m to 2 decimal places. Okay. So this bit here, right? So both of these values. So it's the probability that the first value is greater than 32 and the second value is greater than 32. So listen like this: probability x is greater than 32 and probability x is greater than 32, which is 0.16. So because they're the same, it's effectively that squared equals 0.16. So probability of just one of those x is greater than 32 is the square root of that, 0.4. Okay, because that times by itself gives you 0.16. Okay. Now, what we then got to do is find what the probability of x is greater than 32 is. Use the Z distribution again. So standardise it. You've got 32 minus m, the mean, divided by 2.4, the standard deviation, and we're told that is 0.4, and we can use the Z tables for that. Okay. This is the points table. Okay. The way it works is when you're trying to work backwards, you're given a probability and you're going to work out what this Z figure here is. You simply look it up on the table. So 0.4, so these are p-values. Okay, 0.4 is there, right? And the corresponding Z value is there. And it operates on when you've got a probability Z is greater than. This amount is 0.4, and then we can use the points table. So it corresponds to 0.2533. So what that means is that this 32 minus m over 2.4 is 0.2533. Then we just rearrange that and work out what m is. So to multiply by 2.4 and then make m the subject, you should get 31.39. It's 2 decimal places. Okay. Next part. So Geo now changes the mean to 4, standard deviation to 8. Computer program generates 5 independent values from this normal distribution. Find the probability at least one of these values is negative. Right, so here, that's the new information. I'll just use y, a different variable, because it's it's all just changed. Mean is 4, variance is 8 squared. Okay, find the probability at least one of these values is negative. What that means is probability that either 1, 2, 3, 4 or 5 is going to be negative from 5 independent values. Now the simpler thing to do is to just consider the probability that 0 is negative and subtract it from 1. Okay, because probability of at least 1, that is 1, 2, 3, 4, 5, must be the same as probability of 1 minus 0 negative, because 0 is the only one that's not being included here. Okay? This effectively means, of course, that all of these are positive, isn't it? So if 0 are negative, that means all of those ones are positive. And we've just got to find out the probability of that and subtract it from 1. So we'll just set on that then. First thing, work out the probability that y is negative. Okay, and that's the z distribution again. Probability z is less than 0. What we want, minus mean over standard deviation. And that's the same as probability z is less than negative 0.5. Once again, I'm going to use my normal curve in order to do this. Okay, so working out probability z is less than negative 0.5, exactly the same scenario as before. So that's negative 0.5. The normal tables work on positive values, so that's 0.5. Rather than work out that area, we just need to work out that area instead. Okay, so probability that z is less than 0.5 from the tables, because that's how the tables work. They work up to a particular amount. So probability z is less than 0.5 is that. So up to there, 0.6915. So subtract that from 1. Gives us probability z is greater than 0.5 is 0.3085, which of course means that probability of this shaded area here is the same, 0.3085. So that's our probability that z is less than negative 0.5, which is probability that one of these is going to be negative. So the probability of it being positive, okay, is the other way around, 0.6915. Now you could say, I could just go straight from that to this, just looking at the numbers. Yes, of course, but it just helps you to get an idea of the context of the whole thing, what all of this actually means. Okay, I'm trying to find the probability that y is negative and the probability that y is positive. Okay, so what we're going to do, we've got 5 independent values. Okay, so all 5 are positive. Okay, so positive, 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 positive. So that's 0.6915 multiplied by itself. Let's just change that 5 times. That's better. And that gives us, let's just change that again. So it deepens the video. I'm not going to just change it just to tell the presentation. So probability at least 1 is negative is 1 minus 0.6915, which is what we were after. Okay. 1 minus 0.6915 to the power 5. Work out that is 0.8419. Okay, that's it. Hope you got something out of that. Okay, I'll see you for the next one.